All right, so we're gonna kind of try and reinforce what's going on with current and voltage in both series and parallel. The voltmeter and the ammeter have to work a little differently, right? The voltmeter sees how far you're pushing stuff, how hard you're pushing, and the ammeter sees how much is going through there. So this is normally a thing I have you play with and spend like a whole day on and stuff. This is going to be kind of hard to exactly see what's going on and that kind of stuff. But we'll do a couple little quick ones here, and then I'll jump to the board and have you do a couple there with me. So in order to have current take place, we have to be connected back through to the batteries, right? So we've got batteries right here. I'm just up to 2 of the batteries right now. So if I go from here to 1 battery and then to the ammeter you have to hook up in series because it's got to see what the flow is. So I have to hook up in series with that. And if I do that, I don't know if you can see the light bulb is lit up, right? The light bulb is lit up and we've got a current of 200 milliamps, right? So 200 milliamps, I'm going to go ahead and add a second bulb to this, right? If I add a second bulb to this, all the electrons have to go through both bulbs because we are setting this up in series. So it is going to the first bulb from, I've got too many wires, you can't tell what's going on there. From the first bulb to the second bulb, where we then are like, so, things are popping off. So hopefully you can kind of predict after doing the simulations and stuff, if we add a second bulb in series, this one just won't grab the screw on there. There we go. Where's the end of this one? What's going to be true about the brightness? What's going to be true about the current if we have to go through 2 of these? Now it's only at about 150 milliamps. So I went from a little over 200 milliamps to 150 milliamps. So it dropped the current quite a bit. I actually thought it dropped it a little more. These are supposed to be the same bulb, so it should have doubled the resistance. So it should have cut the current in about half, but it's a little bit more than that. I guess the wires are stealing more of that than I'd expect. But the light bulbs are both lit up again, but they're lit up just a little bit, kind of like what we saw in the simulation. We'll go ahead and go over to 3 batteries. Well, let's go ahead and go clear over to 4 batteries so we can get a good bit of brightness. I go over to 4 batteries. Now my light bulbs are quite a bit brighter. You can actually see them on there a little bit. And we are up to 240 milliamps. I'm going to go ahead and add a 3rd light bulb. Doesn't matter which side of the ammeter I put it on. So this light bulb, I can jump over here. Notice I disconnected. They all turned off. And then we hook this one up. So this is the simplest way to build things, right? The nice thing about series is it's really simple, right? You just go from one light bulb to the next, to the next, to the next, and they go. Now we're lit up again. We are not as bright as we were before, but now we're down to 200 milliamps, right? So my current drops each time as I go to do that, right? And now if we think voltages, I have 4 1.5 volt batteries. So that should be 1.5 volts, 1.5 volts, 1.5 volts, 1.5 volts. So it should be 6 volts, right? Is my theoretical voltage. So with a voltmeter, you hook it up in parallel because you need to just kind of let it press up against you and see how hard it can push, right? So my voltmeter is right here. My theoretical voltage is 6 volts. This thing only reads to 5 volts, but you usually don't get all of that voltage. So I'm going to go ahead and touch my voltage to the outside on both of these. So we go here and we go here. And it's actually about 3.5 volts. So it has lost a lot of voltage along the way there. Oh, and we completely lost. We have no voltage. Everybody's off now. Somebody became disconnected there. There we go. So it's lit back up. 3.5, not quite 3.5 volts. So if I measure that's my output of voltage. If my output of voltage is 3.5 volts, I need to spend that voltage by the time I get back around. So if but I can't put my voltmeter in line with it because it'll cut everything off. So I touch my voltmeter to either side of one light bulb, and whoops, that's backwards. Either side of one light bulb, that is about 0.5 volt. I do a second light bulb, about 3/4 of a volt. third light bulb, about 3/4 of a volt. So that's only about 2 volts. And we had a little over 3 volts coming out of there. So where's the rest of the voltage going? Well, a little of it is probably going to the ammeter. That's supposed to be low voltage, but it's probably not full on no voltage. Oh, backwards. No, we're not getting much. If it's anything, it's not really registerable there. But the rest of it would go into the wires and that kind of stuff, right? When we do them on the board, in theory, we just ignore that. But in practice, we do see some of that voltage is lost in the wires and stuff too. So we will switch and go to parallel now. So now in parallel, I've just dropped to 2 batteries. I have 2 bulbs. They are both lit up. Whoa. They're both lit up, but I can unscrew one of the bulbs and the other one stays glowing just fine, right? So when I have both of them screwed in, they're both going just fine, but the paths are independent of each other. You can see the green wire coming through. The electrons can come here. When they get to here, this is that Y split kind of thing. The electrons can either go through this light bulb and back around, or they can go up this way and back around, right? So you have multiple pathways that those electrons can go, which means that those pathways are independent of each other. So this is where one light bulb can break and it can still stay on. This is how we wire our houses, right? You don't want to have to turn on the microwave so that your TV can work, right? That would be dumb, right? So your TV breaks, your microwave will still work. Now, if we clip this wire right here, then this doesn't work because this is still in line with that. So like this is where you would have to put your circuit breakers, right? Is in the path before the Y splits and that kind of thing. So if we were to measure current, the current here would be more because it's before the Y split, but the current going through this bulb and the current going through this bulb would be the same. That takes quite a while to set up and all that kind of stuff, but those currents would be the same. The voltages would also be the total voltage. So I can pop my voltmeter on here. Each of them will have the full volts. So we have 2 batteries. So in theory, it should be 3 volts. We already know it's going to be a little less than that because there's resistances within the batteries and all that kind of stuff. So my 2 are about 1.7 volts. One of those light bulbs is getting pretty bad. Oh, somebody lost connection here. There we go. Light bulbs are lit up kind of again. So if we touch here and here, 0 volts. That doesn't make a lot of sense. What's going on? My voltages are not, or my light bulbs are barely lit up. There we go. So we are struggling to get this guy to work. 0.5 volt. That's not right. Yeah, my voltmeter is not working right now. Anyway, we'll jump to the board and write some problems on the board. Some having trouble with that voltmeter. All right, so we look at a nice simple circuit. This circuit would be in series, right? Because you've got one loop, the Kirchhoff loop rule, right? So every electron coming out of here is going to have to go through 1, 2, 3 light bulbs, right? So they're gonna drop a little bit. I'm showing 2 batteries here, so 1.5 volts, 1.5 volts. If they don't tell us something different, we just assume it's a 1.5 volt battery. 3 equivalent light bulbs here. So if we want to figure out some things about this, I have 3 volts coming out. So assuming the wires are 0, which is what we normally do, I have to spend those 3 volts before I come back. So this would get 1 volt, this would get 1 volt, this would get 1 volt. You've now spent your 3 volts and you come back. You come back around to here, right? So if we wanted to know what like the current was or something, we'd have to know the resistances. So if we just assume the resistance is 1 ohm for each of these, right? Because they have to be the same. If the resistance is 1 ohm for each of those, and we said, well, what's the current anywhere, right? So your voltage divided by your resistance is your current. So your current would be 1 amp everywhere there, right? And you could do an equivalent resistance where you say, well, I'm going to just add these 3 together and say this is the same as, that is an ugly drawing, a 3 ohm light bulb and a 3 volt here, where you say, well, 3 volts divided by 3 ohms is still going to give us 1 amp. 3 divided by 3 is 1, not 3. Right? So we can do an equivalent thing where we start to smush them together. If, on the other hand, we do it in parallel, you need a Y. So this would be where our Y is. So if we set up this same one where we have 3 volts here, now each of these would get 3 volts. So if there's still 1 ohm light bulbs, right? If there's still 1 ohm light bulbs, then you would do 3 volts divided by 1 ohm, and that would give you 3 amps. And then here you would get 3 volts divided by 1 ohm, and that would give you 3 amps. And 3 volts divided by 1 ohm, and that would give you 3 amps. So you'd have 3 amps here, 3 amps here, 3 amps here, but you'd have 9 amps here because that's before the break. So 9 amps, 3 amps, 3 amps, 3 amps, right? If I wanted to draw the equivalent resistance for this, you add the inverses of the resistors together. So instead of adding 1 plus 1 plus 1, you would do the inverses of those, and then that would equal the inverse of the total. So you do 1 over 1 plus 1 over 1 plus 1 over 1 equals 1 over the equivalent resistance. So that'd be 3 equals 1 over the equivalent resistance. So that's going to be the equivalent resistance is 1/3. Right, so it's actually easier to go through. In practice, with little light bulbs and little batteries, it ends up that the chemical reactions just kind of can't keep up with that. So you see a little bit less current than you predict because the batteries just can't perform that well. If you have bigger setups and houses and that kind of stuff, you don't see that kind of thing take place. Right, so hopefully that gives us a little better handle on how to start drawing these and adding these together and that kind of stuff. We'll, normally we work with these a little bit and we work some problems together. But I think, trying to do these at home without getting your hands on them and stuff is a little bit harder. But I don't want to go too fast through them as we're doing this. But let me know if these are too confusing, if we're going too fast, all that kind of stuff.